Hi, algebra students. We're going to continue our work with solving equations. Today's work is going to be solving equations with variables on both sides of the equal sign. So I'm going to share my screen so you can see today's PowerPoint. We're going to start out with a warm-up, so grab a piece of paper and go ahead and try these problems on your paper. Pause the video and then come back and join me after you've had a chance to try them. Okay, welcome back. Let's go ahead and go through these. On number 1, you should have noticed that you have some like terms to combine right away. So I have 4x minus x. That leaves me with 3x. I bring down my plus 3, and it's equal to 24. Next up, you should have subtracted 3 from both sides, leaving you with 3x is equal to 21. Divide both sides by 3, and hopefully you got x equals 7 for number 1. All right, let's look at number 2. Number 2, you needed to recognize that you needed to use the distributive property in here. Remember, when there's no number listed, we can draw in a 1 in front of the parentheses to help us remember to distribute a -1. You should have brought down 8x. That's not part of the problem right now. Next, I'm going to distribute -1 times 2x, which is a -2x. I'm going to distribute -1 times -3, which is a +3. And that's equal to 9. Combining like terms, 8x minus 2x, 6x, plus 3 equals 9. And next step should have been to subtract 3 from both sides. That gives us 6x is equal to 6. Our last step is to divide both sides by 6. And that results in x equals 1. Okay, hope you got those right. Let's look at our next slide. It talks about what we're working with today, which is, again, solving equations with variables on both sides. It says your goal is to get the variable isolated on one side of the equation and the constant term isolated on the other side. We're going to be looking at extra practice problems beginning on page 15 in your journal. So go ahead and grab your journal, open it up, and let's look at practice problem number 3. So if I look at number 3, I see I have 3k on the left and 8k on the right. Those are my variable terms. I have 45 and 25. Those are my constants. They don't have any variables with them. So our goal is to get all the variables on one side and the constants on the other. So I'm going to go ahead in this problem and get all of the variables on the left. So if I look, I already have 3k on the left, so I'm going to leave that alone. What I would like is 8k to join 3k over there. In order to move things from one side of an equals to the other, remember you have to do an inverse operation. So since 8k is positive on this side, to move it here with 3k, I'm going to have to subtract 8k from both sides. So I'm going to start there. So right below 8k, I write minus 8k. And I'm subtracting it way over here from 3k. Notice I didn't write it under the 45 because they're not like terms. I simplify. 3k minus 8k is a -5k. I bring down the positive 45. I don't have any variables on the right anymore. I just have my 25. So now it looks like the two-step equations we were working with last week. My next step is to subtract 45 from both sides. And I get -5k on the left is equal to, and when I simplify this, 25 minus 45 is a -20. Now we have one more step. Divide both sides by -5. And we should get k is equal to a +4. All right, that's what our goal is today. Get variables on one side and constants on the other. Let's look at a couple more examples. So in this first one, Again, on the left, it looks like I have an 8, 6x, negative 10x, and on the right, a 16 and a negative 8x. So we're still going to use our same procedure for solving equations. We look to see if there are any decimals or fractions we can simplify, and I don't see any of those in this example. Next, I would look for parentheses and maybe some distributive property, and don't see that. Our next step is to look to see if there are like terms on each side of the equal sign. So if I look on the left, I have a 6x and a negative 10x. Those are like terms. I'm going to go ahead and combine those as my very first step. So I'm going to bring down my 8. I haven't worked with that yet, but I'm going to combine these. 6x minus 10x. I'm going to go ahead and write what that is, which is a negative 4x. Write down my equals. And on the right side, I still have 16 minus 8x. Okay, now what's the kind of problem we're working with today with variables on one side and constants on the other is our goal. Again, I have a negative 4x on the left. I'm going to leave that there. I would like this 8x to be over here with that. So I do the opposite of what the sign is here. Since it's negative 8x, I'm going to add 8x. Be very careful that you bring the variables with you. If you leave off the x, you're going to think, oh, I combine it with this 8. But that would be incorrect. And again, this is negative, so I should be adding 8x to both sides. And I'm going to add 8x right below the 4x, because those are like terms. I bring down what I have, which is 8. Negative 4x plus 8x is 4x. Equals, and I'm left with 16 on the right. All right, now I have a two-step equation. I have my variables on the left, so I'm going to leave that alone. I'm going to subtract 8 from both sides. And I get 4x is equal to 16 minus 8, which is 8. Divide both sides by 4. And I get x is equal to 2. All right, example 8 of the extra practice. This time I have, looks like lots of distributive property to work with. So I'm going to start by doing the distributive property on the left. So I'm going to distribute 2. 2 times 4b is 8b. I distribute it to the negative 6 and I get negative 12 is equal to, on the right side, 4 times 3b is 12b. And 4 times negative 7 is negative 28. All right, so let's look at what we have at this point. On the left, I have 8b and negative 12. Those are not like terms. This has a variable. This is a constant. On the right side, I have a 12b and a negative 28. This has a variable. This is a constant. So I need to get my variable terms together. So again, I'm going to go ahead and put them on the left. This is positive 12b. In order to get it to go over to this side, I do the inverse operation, which is to subtract 12b. So I write it below there, and I bring it over, and I'm combining it with the positive 8b. So subtract 12b. 8b minus 12b is a negative 4b. I bring down my negative 12 equals, and on the right side I'm left with, and I'm going to be very careful that I don't lose a sign, a negative 28. Next, two-step equation at this point. I'm going to get my constant terms on the right, so I'm going to add 12 to both sides. Negative 28 plus 12 is a negative 16 on the right. I don't have any constant terms on the left anymore. I bring down my negative 4b. At this point, I have multiplication. To undo multiplication, I divide both sides by negative 4. And that's going to leave me with b is equal to a negative divided by a negative is a positive, and 16 divided by 4 is 4. All right, let's look at the next slide. We're looking at extra practice problem number 11, and I'm seeing Distributive property again. So let's start up here on this side. So on the left, I'm going to distribute 6. So 6 times 4s is 24s. And 6 times 12 is a positive 72. On the right side, I'm going to distribute 8. 8 times 3s is 24s. And 8 times negative 14 is a negative 112. All right, again, I'm going to work on getting variables on the left. Remember, it doesn't matter. I could choose either one. I could choose to get variables on the right and constants on the left, or variables on the left and constants on the right. But I'm going to go ahead and try to get all my variables on the left. So I'm going to leave this 24s on the left. It's already there. But I'm going to move this term so that all my variables are on the left. So I'm going to simplify. 24s minus 24s, that's 0. Bring down what I have left, which is a positive 72, equals, that's a 0. Bring down what I have left, negative 112. Now I look, I don't have any variables. There's nothing to divide by or simplify at this point, so I need to look at this. Is 72 equal to negative 112? Is that true? Nope, it's not true. So our solution for a problem like this, where we get two things that don't make sense being equal to each other, we write no solution. All right, let's look at example 12. Okay, again, I'm seeing some distributive properties to work with. So I'm going to start on the right side and distribute that 8. So 8 times 2f is 16f. And 8 times a positive 3 is a positive 24. I'm going to bring down my equals, write down what I have left on the left, which is 16f plus 24. Now you may be noticing something, but suppose I didn't, and I continued trying to solve this by getting all my variables on the left. So I'm going to subtract 16f from both sides. And I look and it's like the last one. I go, uh-oh, my variable went away on the left. I'm left with 24. I look on the right side, no more variables on the right. I just have a positive 24. Now, before you write no solution on this, look at this one. Is 24 equal to 24? This time our answer is yes. It is equal to 24. Anything is equal to itself. And when that happens, we call it an identity. And so the solution to this problem we would write as infinite solutions. There are many answers that we could put in for f, and they would all work. So I'm going to write infinitely many, if you can read my writing, solutions. All right, let's look at the next slide. Okay, the next slide has today's assignment. Today's assignment is in the book. So if you're in class, you can use one of the books from the shelf. I've also included in today's agenda copies of the textbook pages that you can use. Or if you go into Schoology, there's a link for you to find the textbook. So you can just go to the algebra textbook, page 23, and complete these problems. Go ahead and show your work for the problems. Use your warm-up from today. It's the same piece of paper. When you finish that, if you have some time after you finish, you can try extra practice number 5 in your journal. I'll go ahead back to that last slide if you didn't have a chance to copy that down. Maybe I'm not. Again, all of this is in Schoology. It's also on your agenda for today. So good luck, and I'll see you next time.